Okay, so that was a good thing to work through. Now we can better understand why the product rule is the way it is. I find it more helpful to write out the product rule using function notation rather than the dependent variables u and v. So let me go back to having f is a function of x, g is also a function of x, and we are trying to calculate the derivative of the new function f of x times g of x. Well, that is going to be f of x times the derivative of g plus g of x times the derivative of f. Now, written in operator notation, I would read that expression out loud and say this is f d on dx g plus g d on dx f. And I am suppressing the variable x there just to avoid saying a mouthful. Notice this formula is very much what my talk about differentials was expecting me to say. F dg plus g df, that's the derivative of f times g. Now, written this way, I have a much better way to calculate derivatives of functions where I'm multiplying together two different things which I could have done derivatives of separately. So here's where I needed my derivative of the e to the x function. Let's look at the function f of x equals x times e to the power x. First of all, we're going to find the first derivative of this function. And here, part B, it says find the nth derivative, f to the power n in parentheses. So this is not a notation I've used yet. When I have too many tick marks up top to actually draw them all out, I'll just write the number of them that I'm expecting to have instead. And I put it in parentheses to show that it's different from an exponent. We'll get to that for the second part of this problem. For the first part of this problem, the first derivative of this function, f prime of x, this is the differential operator d on dx applied to the function x times e to the x, and I'm going to use the product rule. I see I have two different functions multiplied together. To use the product rule here, my formula is the first function times the derivative of the second, plus the second function times the derivative of the first. Here, f prime of x is equal to x times d on dx applied to e to the x, that quantity plus e to the x times d on dx applied to x. Okay, well, I know how to do both of these derivatives for the smaller pieces. As I was saying before, the derivative of e to the x is just e to the x. The exponential function is its own derivative. Over here, derivative of x is just 1. dx on dx equals 1. That should be, I like that sound of that equation. d on dx on dx is 1. Okay, let's put those pieces together. For my derivative, I've got f prime of x equals x e to the x plus e to the x times 1. So I'll go ahead and factor out an e to the power x, and I'll call this quantity x plus 1 all times e to the power x, just as a matter of convention, I like to put the polynomial part first before the exponentials.